SF6 is an inert gas and thermally stable gas. When I say inert, it means there is no chemical reaction that will occur like mineral oil. In the previous video, we were discussing about oil circuit breakers where oil is used as a arc quenching medium. So whenever the oil uh, quenches the arc, the carbon particles will be produced. So there are some chemical reactions in mineral oil, but no such problem in SF6 gas. And thermally stable means there is no decomposition that can occur in the SF6 gas. And the main property of SF6 gas is it has got good arc quenching and insulating properties, and it has a strong tendency to absorb free electrons. So the arc between fixed and moving contacts exists because of the ionization or electrons present in the gap. If those electrons are deleted or absorbed, then the current cannot flow between the contacts in the air gap between the contacts. So absorbing the free electrons is possible with the help of SF6 gas used as a arc quenching medium, and its density is 5 times that of air and its heat conduction is 1.6 times that of air. It is like compared to air, this can conduct the air very fast, conduct the heat very fast. It is also non-inflammable, non-poisonous and odorless. So these are the properties that makes suitable for arc quenching in circuit breakers. Let us see the construction of circuit breakers, SF6 circuit breaker. So this is the moving contact and this is the fixed contact. Moving and fixed contacts are hollow cylinders. They have holes on its sides and they are coated with tungsten, and there is a reservoir for keeping the SF6 gas stored, and when the contacts are closed, the surrounding space between in the contacts will be filled with SF6 gas at some pressure, and a separate reservoir is used for storing the SF6 gas. Yeah. So the tips of both the contacts are coated with copper and tungsten arc resistance material so that the contacts will be kept safe even if the arc is struck often. Since the SF6 gas is costlier, we can recondition and reuse after each operation of breaker. Unlike mineral oil used in oil circuit breaker where the oil has to be replaced, here we can do some recondition and you can reuse the SF6 gas for multiple operations. So hence it is suitable for high voltage operations. It's ranging from 115 kilovolt to 500 kilovolt. Let us see the operation of SF6 circuit breaker. So during no fault condition, both the contacts will be in closed condition, and as I said before, the contacts are surrounded by SF6 gas at a pressure of 3 to 5 kg per centimeter square. When contacts are opened, an arc is struck between fixed and moving contacts. So the valve between the arcing chamber, this is called arcing chamber, and the valve opens and the gas SF6 gas at 14 kg per centimeter square enters into the arcing chamber. Now this high pressure SF6 gas will absorb the free electrons that are present in the arc. So therefore the free electrons become immobile negative ions. That is, immobile means they cannot move freely from one point to the other. Therefore the current cannot flow through the air between the contacts. So hence the medium between the contacts recovers its dielectric strength at a faster rate and arc can be extinguished. So when the medium between the contacts recovers its dielectric strength faster, that is, a deionization happens and the arc cannot restrike further. This is how an SF6 circuit breaker in a substation looks like. So these are the incoming lines and these are the outgoing lines. This is the place where the arc quenching happens. Advantages of SF6 circuit breakers. As I said before, SF6 gas is non-inflammable and the byproducts produced after decomposition are not explosive, and no current chopping is possible and capacitive currents are interrupted without restriking. In the previous video I told you about current chopping and capacitive currents interruption. Anyway, we will discuss about these two topics in the further videos. Arcing time is very short because SF6 gas quenches the arc at faster rate, therefore the contacts are very safe. And one more thing is you can keep the contacts gap very small. You need not bring the moving contact very far away from the fixed contact. Even a small gap is enough to quench the arc. The main disadvantage is the byproducts produced when the SF6 gas is released may be dangerous to the operating personnel. And since SF6 gas is costly, the circuit breaker itself becomes costly, and SF6 gas has to be reconditioned after every operation of the breaker. So hence an additional equipment is required for this purpose of reconditioning. Thank you.